within this particular reject table, which includes what we call row ID job, which indicates row ID per job run, and the error description, that why this particular what we call record got rejected and from which source system, which means generation of unique ID per for each source system record, and the last update date, which is most recent date for this particular record, and rest of them are what we call user defined columns, right? Which means first 4 columns are system defined. Out of them we would be primarily using error description just to know like why record has been rejected, right? So that part we have discussed, which means this reject table we have discussed, and also normal staging we have discussed. But we have other tables, like we have a raw table, yeah. So which means raw table will be used in order to perform data archival, which means how are we going to archive the data that we get from the source system. For that we use what I call raw table concept, which means we need to configure audit trail. Based on that we can start getting the data archived in this particular table. Why do we need this? We need this, let us say we have done as per the flow or data flow process, we have done landing part, staging part, loading part, or down the if you look at the what I call downstream layers within the data flow process, like a match, merge or unmerge or whatever, right? Something went wrong and data got corrupted, or something went wrong with respect to data. So how are we going to recover that kind of data? So that is where if we archive it within this raw table, we can always cover it back, so that we can always perform what I call the rest of the operations against with archive data. So that is where raw table is going to help us. Yeah. So in raw table we can archive the data based on 2 primary options. One is what I call based on the number of loads, yeah, which you can see for any base object table. You can see here based on the number of loads. So which means we can archive the landing data. So question from Dana was landing table data or staging table data would be archived. What you are trying to ask, right? So answer is landing table data. So before we transfer the data to the staging table, we archive it. Yeah. So which is what will be done here. Oh, it's breaking. Huh? 1 minute. Yeah, I think now it should be okay, right? Yeah. So here we archive the data, what I call from the landing table data. Yeah. So based on the number of loads and number of what I call hours or days or weeks or months. Yeah. Yeah. Go ahead, Vinay. Vinay has got a question. So others, please go on a minute.
No, Narasimha, the doubt was the doubt was like landing is truncate and load. So every time we do the loading, right, then we'll enable this feature.
No, once you enable it, so it's a one-time job. So when you run this stage job, right, so that time it is going to be truncate and followed by load. Meaning what? So you will have previously processed data in the raw table plus current processed data in the raw table. But staging table is truncate. Remember, it's a good question. Truncate followed by load is applicable for staging table only. I repeat, truncate and followed by load is applicable only for staging table. So it is.
So landing will have entire history.
No, not landing. Raw table. raw table will have the complete history. This one I was
Then
talking
what
about.
about how about landing?
Landing data, just a source system data, right? That you will not
Correct.
have it,
So
what you call, you'll have only latest data.
okay, but even then landing will also be kind of truncate and load daily.
Oh, that depends on like what you do from ETL. It could be a truncate or it could be what you call even append also. It depends like what you are going to take care from the external systems. So which is not the
Correct,
scope of this
but
MDM at all.
if we maintain history data in landing, let's say I go on appending, then the logic from landing to staging should be able to get the latest data into staging, right?
You will get it, but the problem is unnecessary we are processing the complete data which is not required. For example, since last 10 days you are trying to keep on appending the data into the landing table. If you try to process the previously processed data, which is a overhead, right? So we need to avoid that as much as we could. So here in landing get only latest data and in staging layer perform what you call archival. So that you will have archive data as well as what I call good data. Both will be taken care as part of staging. So it is not advisable to maintain the archival in the landing layer. If you do that, the stage job will take much longer time to execute job. Because let
Okay.
us say 100 times if we, let's say since last 1 month or 2 months, you keep on appending the data in the landing table. So what will happen? There will be too many rows in this particular landing table, right? Yes or no? In order to process those records, then it will take a lot of time in staging also. As we all know that MDM is very critical with respect to what we call time taken to process the input data because we build lots of quality rules over here which would need lots of CPU power. So if you try to try to process the data which is already processed, then what will happen? It would take much longer time. So we need to cut down as much duplicate data as we could get it from the source system. But here you focus on the data so it makes sense. So which means what? Oh, voice is breaking, huh? So what happened today? How are we going to what you call now it has come up. Thanks, Anis. Now let us get into what I call how to build what I call same filter option by using what I call another transformation which we call case or switch what we call transformation of what we have here. So this is also one of the stage, the processing stage which will be used to limit the number of rows, remember. But the major difference between the filter stage or external filter stage against with this particular stage is what? Here the switch stage is going to work based on case blocks like case 0, case 1, case 2 and so on. Which means what? These values will be derived from a column. Let's say column name is, let's say, gender code, or column name is, let us say, age. Now if you want to capture only what we call the age with what we call 40 in one target, so we can define a case 40 then for age column and start getting the data transferred to the what we call one target table where we are going to maintain the customers whose age is 40. Similarly, we can have one more case block, let's say 50 or 60. Based on that, we can start capturing what we call corresponding data in corresponding target. Yeah? So that is what we do with what we call switch case. Yeah? So which means what? This is an optimal version of what we call switch case. In case of what we call normal filter or optimal version of filter stage, not switch case. So which means what? We use what we call the case blocks, right? As and when the case is going to get satisfied, it is not going to execute other blocks. So but in case of if else, which means filter irrespective of whether the first condition got executed, but still other conditions also will be executed. Yeah. Yes, Prashanti. No audio. What happened? Others could able to hear me, right?
Yes.
Oh, Prashanti looks like she has a problem. Yeah, please log off and log in. Yeah. Now, let us start what we call making use of this switch stage so that we can start building case blocks over here. Then output of this switch case will be sent to, let us say, sequential file or any other target. Okay. Now, let us start building what cases. Before we get there, let us define what we call columns within row generator. I picked up this row generator because it's easy to configure, so we don't need to worry about the source system data. So we ourselves can use our own algorithm to build our own sample data here. Yeah, I'm doing it, Prashanti. Yeah. Can you try now? Yeah, could you able to hear me now, Prashanti? Yeah, I think now it's okay, I guess, right? Yeah. Yeah, which means this is how we configure what we call switch stage. Yeah? So let us start getting into what we call configuring the switch stage. Yeah? So here the first and foremost thing here is what? Which column that we are going to use for what? Applying a case. Is it going to be column 1 or column 2? Whatever. And select. So column 1 we have selected here. And then case values. Can you see here? User different mapping. Here you can define case values. So which means we can define n number of cases. Yeah. Based on that, we can start capturing the output in the respective targets. Yeah. So let us start building that over here. Yeah. So let me summarize. Prashanti was asking question. So we are just using switch stage to capture the output based on the case blocks. Prashanti. So for that we have just defined data, we are just using the data from the row generator and then start building case blocks for any column. In this case, we have just taken C1 column and start getting the what I call switch case configured. Yeah. Then we have other options. I'll talk about it. We have different options here: fail, drop, and output. Fail means what? Each and every record from a given input data should get matched with what we define as part of case block. If one of the record is not going to get matched with this case block, then job would get failed. Which means what? It is mandatory that each and every record should get matched with what I call case values. If not, job will get failed. But if you use a drop option, then what it does, we can capture only matching records. In this case, we have what we call case equal to 3, which indicates what? We can capture only the input data where we have a C1 value is equal to what? 3. The rest of the records will be ignored or skipped. So that is what would be done with a drop option of what? Switch case. Yeah? Now we can go to output tab where we can map the data from left link to right link so that data would be transferred to a target. The target here is what? Sequential file. Yeah? So now it's similar to what I call, just to make it very simple, like how the switch works. No? Let me just open that notepad. So you guys would have used, let's say, if else conditions, right? If, let us say, column 1 less than 2, then what happens? Then do something. Let's say A equal to 2. Yeah, else if C1 greater than 3, then A equal to 5. Then and so on. Else, let's say A equal to, let's say, some value. Yeah? This is how it works. Let's say AND. Now, same thing. How do you do it in what I call a switch? Or let us say C1 equal to 2 and C1 equal to 3, else is this. Now, how do you do it in what I call switch case? In case of switch, what happens is you will have case block. Let us say column name first, which is the label, and column values will be part of case, like case equal to 3 and does A equal to what? 55. Then break, which means what? As and when this case block is going to get satisfied, it is going to break or come out from this particular case, switch case. Similarly, case equal to what? Other values. What are those? 2, right? Case value 2. Yeah? And case is 2, right? Then A equal to some value and break. And then you'll have what you call default, which is again what you call default thing, which is equal to what? In case if the input data is not going to get satisfied in these cases, control will come out to default and we perform executing some what I call some expressions or whatever within this case block. In this case A equal to 555. Yeah, this is how what we call we configure what? Both switch and filter. Remember, first is equal to what? This is the complete block. It's equivalent to filter stage of what we discussed yesterday. This is equal to what? We have what we call, this is what we call switch. Yeah? Which we are going to discuss today. Yeah? So which means what? As and when this case block is going to get satisfied, this will be executed, which means whatever expression that we have within the case block, then it will break. So which means case 2 default will not be executed. So this will come out from this switch case. So that's what happens in this case. But in this case, which is filter, let's say this got satisfied, A equal to 3. Again, this is going to check C1 is equal to 3. If not, it will not. Again, if you have multiple else if, right? Yeah, multiple else if conditions, right? It is going to what I call execute all the else if blocks, which is a overhead thing. So to avoid that, if you use switch case, they are going to save a lot of time. So which means for the performance reasons, it is always advisable to use switch stage rather than what I call filter stage. This is a major difference. You know? Now we will get into what I call designer. Yeah, let us define. I think we have already defined, right? One case block, yeah, and we are going to transfer that data to a target, which is sequential file. Yeah, browse to your location. SQ underscore switch case, right? I'll just put switch out. With one case, right? Dot txt. Now we have just given the file name and say OK. That's it. Now save it. So you will have what you call, we have only one row, right? In row generator, which is going to get satisfied with this particular switch case. Let us save this. Row gen switch with one case and sequential file is a target. Save it. Yeah, now save, compile and run. Yeah, can you see here? Now from row gen, we have what? 10 rows here to a switch case. But in switch, after switch, we have only one row which got transferred to a target, which is a sequential file. Because in this switch case, we have what is called case 3. Only one case, right? So which means in row generator, you will have 0 to 9, right? 0, 1, 2, 3, 4, 5, and so on. Out of them, fourth row, which is where we will have value of 3, that will get satisfied. Only that particular row will be transferred to a target. So that you can see by getting into this folder and file name. Yeah, can you see here? Only value 3 got transferred to a target. So that's it. Now let us extend this with more case blocks. Click on this one more case and add, let us say 5. Yeah. Now what do we need to do? If you go look at this in the link ordering, you'll have what? 0 and rest of them reject, right? So which means whichever is going to get satisfied with this particular case block, only those records will be transferred. Now we define 2 case blocks, right? Yes or no? Can we capture all of them in a single target? Yeah, which means what? The records which are going to get satisfied with these 2 case blocks where we have values like 3 and 5, right? So 3 and 5, which means only 2 records need to be transferred to a target and rest of them should not be transferred. Yeah, but the job got failed. Now we can see the reason why it is going to get failed. So because what we did here was we defined 2 case values and then single target. Yeah, let it come up. Yeah, this is a job, right? Which one? Trojan switch, right? Where is that? Yeah, this is the one. It's got aborted now. Yeah. Key value, what it called? This is yes or 5. So which is saying is an invalid. So we need to define what it called valid value for that. So how do you define valid value for this here? We have given what we call case equal to 5. So it should work, right? Or let's say case equal to 4 example. So which means in case if you have input data which contains whatever case equal to 5 or 4, whatever, right? It should get matched. Yeah, now it is saying this number is invalid. Can you see here? Which is value 4. Which is what? It's saying output data set number 1 for key. This is 4 invalid. Because the reason here is what? We need to supply right values. Then only it is going to work. Okay? So now if you go and remove this, then it would work. So now we can ask question, how are we going to take care of multiple case blocks? That I'm going to talk. Yeah, one row, right? This is fine. Now we will save this to switch with multiple cases. Okay. Yeah, now let us start adding what we call multiple outputs. Let us say second output is going to be what we call peak. Now we can start adding what we call multiple cases, which is, let us say, 0 or whatever, and start capturing those records. Yeah, can you see here? One row got transferred to this particular target and other row got transferred to the peak, which means what? For every case block, you will have corresponding target. Can you see here? Link 5, where we transfer first case block, second case block data will be transferred to what I call second target. Like yesterday, we have talked about filter stage, right? Where for every condition, you need to have corresponding target. Similarly, in switch also, for every case block, you need to have corresponding target. That is what we have done now, right? Likewise, we can build any number of cases and start getting the data captured in respective target. Yeah? Let's say 4 or whatever. So I'm just using a peak stage here as a target, which is what I call where we don't need to configure anything. So once you just use the target, data will be transferred to that. Yeah? If you use other targets like a file or database, right, every time we need to go and configure. So we can do more examples if we use a peak stage. Yeah? Now compile and then run. Did we define one more case block? I think yes. Yeah, Can you see here 1, 1, 1. So we define 3 case blocks and you can see what you call output in respect to target here. So let's open this particular case. Where is the multiple case, right? This one. Right click and save view log. Here you can 2 peaks we have used, right? Peak means what? It is going to display the output in the console. The console output here means what? Director output. Where you can see we have what is called 0. This is second case block, right? Which got transferred here. And other is what we have value 4 which got transferred. Which means what we have used 2 peaks, right? So 2 peaks output you will see in the director, and other target is what? A sequential file where the first case block output will be sent to that particular sequential file, which is going to be the value 3. That's what I think we have already seen that. So which means what? For every case block you can have corresponding target and capture the output in order to what I call proceed further with respect to job design. Now there is one more concept which we discussed yesterday, which is what? How are we going to capture rejected records? Which means what? Now we have only 3 rows which are transferred to targets depending upon the case blocks what I call met. Now the next question is what? In case if you want to analyze the records which does not matches with what we configure here, how are we going to take care of that? That will be done by using reject or output option of what we have in a switch case. Let us go and start capturing rejected records. Multiple cases with reject. Which means total we have 10 rows here, right? That would be produced by row generator. Out of 10, we have what I call captured only 3 in the targets, but what happens rest of the 7 records? That will be captured in where? By using if not found option is equal to what? Output, which means what? We can output the records which does not meet the what I call switch case or any of these cases, right? Those records will be captured in another target, which is going to be the rejected one. So let me use a file over here and supply file name. Now browse to a location and supply file which is a reject. Switch reject, right? I'll just put switch reject .txt. That's all. Now say okay. So main thing here is what that output, this reject mode is equal to output. That is the main thing here. Or if not found is equal to output. So that we need to configure in switch case. This is the main thing. Now let us save it and look at the what I call unmatched records in this particular link. So this is a normal output link, right? We need to convert this to reject. If you don't do that, you will get error. Can you see here? Missing reject link, because we define property which is if not found is what? Output, right? Yes or no? That would require what I call reject link. So to do that, select this particular link or right click and say convert to reject. Can you see here? Now this link will be what it will get changed. Dotted line with arrow or imaginary line. Yeah. Now save this, compile and run. Yeah, can you see here there are 7 rows which are transferred to what? To this particular reject file, reject link, because 3 rows only we captured in what I call other switch cases. If you go and look at here, 1, 2, 3. So we have 10 rows, right? Out of them, 3 rows are going to get satisfied with three case blocks. The rest of them need to be captured where? In reject link. So that's what we could see over here. Now we can go to what we call output folder, where we can see what we call rejected records. Yeah. So other than what we call 0, 3 and 4, all the records will be available here, which means all the 7 records, yeah, which are not going to get matched with what? This case blocks. Yeah. Like we talked about in this example, right? We have a default case, which means what? So this is the one which is equivalent of what? Rejected records, which means default block which will be executed. So that output will be sent to what? To the rejected file. Yeah. Then the question from Prashant is, what is the major difference between filter and switch in terms of performance? Yes, it's only basically performance. Another thing is here in switch, there is a what is a problem also. We cannot build complex compound expressions or complex expressions. We cannot do that. Yeah? In case if you want to do this kind of only case value check, go with switch case. In that case, switch is much faster than compared to filter. And use filter in case if you want to build complex conditional blocks. So that's what we need to think of, like when to use what. Prashanti? Which means when to use filter stage, when to use switch stage. Yeah. So that's about what I call switch stage. Yeah. Okay, now the next option, which is going to be an important option, especially when we are going to deal with what we call confidential data. So which is what? Fail option, which means fail means what? As I said earlier, every record that we are going to get it from source should get matched with what we are going to define as part of case blocks. Then only job would be succeeded, or else job would get failed. For example, if I use what? Fail option over here, then what happens? These case blocks, only 3 records are going to get satisfied, right? What happens to the rest? Job, 7 records, right, which are not going to get satisfied. So result of this job should be what I call failure. Yeah. Now it should not compile also, because we have different reject link, but the mode of if not found is what? Fail. Can you see here? This is the one. It is not allowed. Now close this and remove this reject link. Now it will work. Only thing is compilation should be okay. But when you run a job will get failed, which means runtime status will be the failure. Yeah, can you see here? A red line with arrow, with especially thick red line with arrow indicates what? In the statistics, right? Which means job got failed. So we can also see that in the director log with a failed message. Go to view status and select with a failed job, or else you can sort this database and sort it. So can you see here? So latest job, it will be in the top, yeah, which is 8:44 a.m. Yeah. Now right click on this view log. Yeah. Instead of randomly checking the file job name, right? You can just sort it. Now can you see here? Here you have the records which is 0. First record is okay. Second record is what? 1. It is going to check whether the 1 is there or not. It is not there in the case log. Yeah. So which means for second record, right? Then job would get failed. Which means what? It is going to check from the top. First record, second record, third record, fourth record and so on. Whenever it is not going to get matched, job would get failed. So it is not going to proceed further at all. It is going to break and status will be what? Failed. So this is very good thing in case if you want to deal with confidential data, because we expect each and every record should get matched, or else what you call we are going to stop making the what you call proceeding further with respect to what you call given input job. Yeah. So which means in that case we use switch stage, or else switch stage with other options can be used. Yeah. Fine. That's about switch stage. Now other things like link ordering part I have explained. Let me recap that. So DS link 5, first output link, link 8, second output link, third output link. If you want to reorder, we can always use it here. Up and down arrow buttons we have. We can always change it. And optionally we have a reject link, which means if we use if not found option as what you call output, then that reject is applicable or else no. Remember, this ordering is going to play a key role. This means depending upon the order, we need to look at corresponding output. So order and this case will go hand in hand. So which means by default, this case, first case will be sent to first target. Second will go to second target. Third will go to third target. Yeah. But if you want to change the like last is first or whatever, right? Then we can change by getting into the link ordering. By default 0, 1, 2, which means what? Indexed. First will be first target, second will be second target and so on. Yeah. If you want we can change it. DS link 5. We have what you call link name also, right? We can see here link name. This is the what I call first case output. This second case output. Third case output. If you want to change, let us say first case output to what I call this is let us say second, which means what? First case output to DS link 8 instead of what I call DS link 5. We changed it. So if you want to change the order, we can always change it. But make sure that you remember like what you do here. Or else, if you try to check one target data in some other target, then you'll have what I call wrong results. Yeah? So we should be very careful. Yeah? If you go to the default option, which is the best option, and arrange the job in such a way that first case will be in the top, second case in the next what I call on the bottom and so on. Likewise, if you arrange what I call multiple targets, then that will avoid all confusions. Yeah? Fine. So that's it about what I call switch case. Yeah. Plus we have what I call selector mode as user defined mapping. So far we discussed about that. We also have other types of selector modes, like we have auto and we also have what I call manual. Yeah? So how do you do that over here? Yeah? Now save this to what I call other modes. Let this be fail or whatever, but we need to talk about non-user defined modes, which means what? Predefined modes, like we have auto hash, right? Which means what? We are going to use, instead of user defined way of configuring switch, we could use what we call predefined options, like we have hash, which means what? Hash way we are going to what we call get the output, remember, which means there is a hash partitioning method. I'll talk about it. Based on that, this guy is going to transfer the data to a target, which means it is going to make use of hash algorithm. Based on that, what we call data will be transferred to a target. So depending upon the partitioning method that we are going to choose, what we call auto option is going to work. But in this case, we have what? Hash partitioning method. In that case, can you see here? 3 records have been sent to sequential file, 5 have been sent to second, 2 have been sent to this guy, third peak. Which means what? So hash, it is going to what we call group set of related records. Some records have been sent to here, some here, some here. Now if you go and look at the output, that's a sequential file where we have what we call output, right? Can you see here? This is what? It's a reject, sorry, wrong file I opened. This one I need to open. Oh, not this. Yeah. 3, 4, 6, right? 6 space 1. There are what I call 3 records which have been sent to this particular target. So which means what? It is going to divide the input data into multiple targets based on the number of targets that we are going to define. So which means based on that, it is going to divide the data and get the data transferred to what I call multiple targets. Now, is it going to work? Because we have how many targets? We have what I call 4 targets. Remember, we can have any number of targets. The hash will take care of splitting the input data into multiple targets based on hash key. Can you see here now? 2, 2, 3, 3. Which means what? It is going to take input data as what I call one input and other is what? Multiple targets. Based on that, what I call hash is going to divide the data into multiple targets by using hash algorithm. Remember. Likewise, we can also add multiple targets, which means if you are not sure about what you are doing with respect to conditions, right, then we can what I call divide the input data into multiple targets based on what? In case if you have very large data from the source system, we can break it up into multiple targets based on hash algorithm. So which means we don't need to build any user defined switch cases. So it itself will take care of splitting the data into what we call multiple targets based on what? Hash algorithm. Now can you see here? So how many records we have? Here we have 0 rows have been transferred here, 4, 3, 3 and 0, 0. Which means what? Depending upon the resources and what I call and the hash algorithm, it is going to divide the data. Remember, it's not that if you use multiple targets, though we have input data is let us say 1 row, it should be transferred to what I call 5 targets, right? So depending upon amount of data that we are going to what I call have from the source, it is going to divide that into what I call appropriate number of what I call targets. Now I define what I call 1000 records in the row generator, which means now it should split into what I call all the targets of what we have here. Here we have 5 targets, right? So which means this data will be split into 5 targets. So depending upon amount of data, we can get it transferred to what we call respective targets. Can you see here now we have what? 2233. What happens to rest? Oh, it is transferred only 10. No? We didn't save it or what? This is 1000, right? So this guy is what we call transferred only. It didn't save at all. It didn't save. We need to compile and run in order to what we call affect that. Actually it should take care. Can you run it, right? So there is a bug here. Now we saved it, compiled it and executing it. Now you can see here, right? 1000 records have been transferred from row gen to switch. In turn, switch has broken down into multiple targets. 196 here, 202 here, 200 plus here and 178 here and 190 here. So which means what? We can break up the input data into multiple targets. This is very much required in case if you want to split very large data into multiple what I call targets. So split the input data into multiple targets. That is where we use what we call this particular hash algorithm. Clear? So it is going to make use of hash method through which it is going to divide the data. That's all we do here. No, we don't have this control. Venkat, the question from Venkat was, can you split this fixed rows using a hash? No, we cannot do that. This guy is going to make use of hash algorithm which you don't have the control. Like whichever the way it is going to work, it is going to divide the data, hash algorithm. So here it is respect to condition, right? No, irrespective of condition, you are right, Prashanti. So without condition, which means hash algorithm, it is going to look for some keys. Key could be C1 or whatever. C1 here. That's what. It is going to take input only C1, which is going to be the key column. That's what is required for what I call hash algorithm to work, which is hash key we call. It is going to take hash key as input and start dividing the data to multiple targets. That's all it does. Yeah? So randomly it is going to split. That's all it does. Yeah? Clear? So any questions here? So that's about switch case. Now we will talk about auto. Auto is also one of the what I call way through which we can divide the data into multiple targets. Now we have used non-user defined mode, right, which is going to be, let us say, auto. So far we have focused on what I call hash, right. Now we will also talk about auto option. So instead of selector mode is equal to hash, we will use auto. So auto, you'll have what I call these failure options, which means what we can also capture this what I call rejected data in the output or capture only what I call auto algorithm, which means what, if you go and look at what I call auto partitioning type, right, depending upon whichever partitioning type that it is going to use, auto is going to work. So which means what, capture only matching records against with R2 partitioning method. So those records will be transferred because we have used drop option over here. Now we can see the job got failed. Why? We can see the output here. Let us go to view status and select what first one, right, because we sorted data based on most recent date. Can you see here, there is a data which got splitted, unhandled conversion on field C1 from source type integer in 32. The destination type is what? Int 8. Which means what? There is a conversion problem over here. Source is what? 32, and target expectation is what? 8. So which is not able to fit this larger than 128 value. So that is why it got failed. Remember, so 0 to what I call 127, which is 128, which is a 1 byte, right? Only that much only it can fit in, which is what? 2 power 8. If it is going to cross, job is going to get failed, which means that's auto part. In case if we define, let us say here, assuming that we have 66 rows that need to be split into multiple targets, then this value will be or is going to fit within what I call int 8. So that's what int 8 means, what? 2 power 8, which is what? 128. So which means maximum value it can take up to 127 or 128. So if it is going to cross, now 66, right? 0 to 65, that is within what I call range of 128. That is why data got transferred to multiple targets. Which means what? We should be careful while using this auto option, because auto option is going to work based on like a character type, which is 1 byte. 1, 1, 1, 1, 1. Only 5 records have been transferred. The rest of them ignored because of what? We have used drop option. If we use fail option, then what happens? Job is going to get failed. If we use output, which means what? Whichever is not going to get satisfied with this particular what I call other than 5 records, whatever, right? Those records will be captured in another link which we call reject link. So let me go and add it here. Convert to reject. Save it, compile, and run. Can you see here? Now we have some data here. How many records? 61 rows. Rest of them 5 rows, right? 5 targets. So which means 61 rows, we captured them as part of rejected link. Now we can go here and look at what I call leftover records, which will be part of reject link. These are the what I call all the rejected records, which is how much? The count, you can say 61 rows. So total we have 66, right? Input. 5 rows have been transferred to targets and 61 rows have been rejected. So which means what? This guy just like what I call 1 byte data will be transferred. 1 byte and 1 row. And other rows we need to take care of it in either reject or drop it off. So input data, if it is not going to get matched, job would get failed. If you select a fail option, job will definitely fail because the input data is much longer than or larger than what we have in target. So that's about what I call different options of what we have in this switch case. So we can add any number of output links and start getting the data captured in this particular what I call So you can also see description here. Can you see here? Here you have, in case if you want to read, understand and start building it, right? Then we can also build it. So which means what? Different distinct values will be stored in each target. No? 1, 1, 1, 1, 1. Rest of them will be sent to what you call project link. This is the one. So that's it about what you call auto option of what we have in switch case. Any questions here? Now we talked about filter stage, external filter stage and switch case. So whatever option that we have, yeah, real scenario is, let us say we have different states data, state 1, state 2, state 3, state 4, state 5. Example, and each state has got a way to identify by using a digit 1, 2, 3, 4, 5. Every state will be identified by using a code, state code or whatever, right? Now, you want to capture what you call, are we getting the different states data or not? To capture that, auto option is going to help us. In case if we get duplicate data or duplicate states data, right? Let's say AP. If you get it 2 times, one row will not be considered, only one will be considered. So if you want to capture only distinct values, only one unique value only will be transferred to a target. The rest of them will be ignored. Which means what? This is going to facilitate us in order to what we call capture whether we got the input data is right or wrong. For example, if you say, or if you use fail option especially, fail is a very good option here, where we can see here, in case if we have input data which does not have unique values, which means what, job immediately is going to fail. Yeah? Because we have only 5, or let us say, I'll remove this reject part. Real time means what? If you want to capture only distinct ones, which means every record should be distinct, then only job would get succeeded. Plus, it should be equal to the total number of targets of what we have, which means 5 states means 5. If you get more than that, then job would get failed. So that's one of the real-time example, which means what? Today's business, we need to focus on 5 states. So we need to get the data only for 5 states, and that too, they all should be unique. There should not be 5 records in the same state. Yeah? So that should never happen. In that case, what we call, we are going to use this particular auto with fail, so that job would get failed in case if it is not going to meet the expectation. Expectation is what? Every state should have 1 record. That we didn't get it here. Can you see here? We have what we call more than 5. So first, what we call case, it is met, so it got failed. So which means what? Depending upon, if we expect this many, only that many things only should come from the source. If we don't get it, job would get failed. Venkat? Can you see here? Only 5 is got matched. Then what happens to this 5, which does not have any way to capture it in what we call target? We don't have it because we don't expect it. We got the data. That is why make the job to get failed. Yeah? This is one of the real-time example. So states data. Similarly, we can think of, let's say you'll have different types of customers, like a tier 1 customers, tier 2 customers, tier 3 customers. So assuming that as per the business, we are going to process only tier 1, 2 and 3 types of customers. In case if we get different types of customers other than these 3, then but we have only 3 targets or 3 output links, then the job would get failed. Which means what? depending upon what is needed for the business, we are going to capture only those records. Yeah? So other than that, what I call, if you get it from the source system, either it could be duplicate data or it could be what I call more than what is expected, job would get failed. Which means if we expect this much, which means 5 records, 5 distinct records, if we don't get it, or if we expect only 5, you go with what I call switch with the auto option, so that it will take care of rest of the record, whether to skip or whether to make what I call rejected, or whether to what I call make the job to fail. That is optional. That's the optional thing, which means what, depending upon criticality of the data, we can select this option, or else we can use a drop, which means we capture only first 5 distinct values to be first 4 distinct values will be transferred to a target. Sorry, 5, right? 5 output lines. First 5 unique values will be transferred. Rest of them will be skipped off. But if you use fail, then job will get. So that's one of the real-time examples. Likewise, we can think of prepaid customers, postpaid customers, assuming that if you get other types of customers, or if you get similar prepaid customers time and again, then job would get failed. Similarly, we can think of many examples, retail industry or healthcare industry. For today's business, we need to focus on only outpatients and inpatients, not other than that. In case if we have other than that, jobs would get failed. Or physicians, different types of physicians, right, belongs to different departments like a cardiology, radiology, dermatology, and so on. Yeah. But for today's business, you need to deal with the patients belongs to what I call these 3 departments. In case if we have what I call, if we get the input data which is other than these 3 departments, then job would get what I call fail. In case if you want to make it to fail, or else you can also drop it off. In case if you get data other than that, in that case, auto option will take care of it automatically. You don't need to go and define what I call user defined case blocks, case equal to this, case equal to this, that, and so on. All such things we don't need to take care here. These are the benefits with respect to switch stage other than performance. Hash will take care of splitting the input data into multiple targets. That is a straightforward based on the hash key. And then auto option is a very good option where we capture the records, especially distinct records, depending upon what we call the number of targets what we have, or number of output links of what we have. Venkat? Likewise, we can think of many what we call real-time examples. Yeah. Any questions? Okay then. So if there are no questions, we'll stop here and we'll meet tomorrow at the same time. What we'll do is tomorrow, it's a weekend, right?